Can you please read it off to yourself right now? Oh, wait. Cool. You might have noticed a couple things in here. Mass was included, and it was stationary. Now, normally, when a proton is on Earth, it'll be pulled down by its weight. But by reading over the problem, it's stationary in a field. Fields make forces. Fields from electricity don't make weight. They make electric forces. So which way must the electric force be so that the proton doesn't move? Yeah, you got it. Up. Are these two forces balanced or unbalanced? Definitely balanced, because the net force is 0 because it's stationary. You know the mass, gravity is 9.8. So you're going to find that the weight is 1.6366 or so times 10 to the minus 26 newtons. That is also going to be your electric force. The question says find the amount of field on the proton. On. On means that it's the test charge. Trying to find the field. We know the force is this number right down here. And what's the value of the proton? Do we use its mass? No. We definitely use its charge. You're dealing with electrical fields. Do the division and you will find the field to be 1.02 times 10 to the minus 7th. And unit? You got it. Newtons over coulombs. Boom. Simple, easy, brilliant. But let's go to number 2 right now. And welcome for the 3rd time I'm trying this problem. No joke. The blooper reel is disgusting. We are going to try number 2 right now. You're going to get an understanding of it. Now, in the beginning, we're trying to find the net electrical field at this point. How many fields are there? You got it, 2. One this way, and one this way. Now, these two charges are the same. So which field will be stronger? The closer ones or the further ones? Yeah, the closer ones. So we're going to have the right field be stronger than the left field. So we already know the net direction is going to be right. That's our answer. Cool. We still need numbers there. There are 2 fields. Are these objects the test charge or the object charges for this point? Since they're making it, like the director just said, they're going to be the object charges. We're going to use this equation twice. Using the charges given, I'm going to find that the right one is 216 and like 5 zeros. I'm going to find that the left one is going to be 15 million with, all the zeros. Now, do we add or subtract them? You got it. We're going to subtract them because they're in opposite ways. When you combine these two, you will get 6,600,000 newtons per coulomb. And which way will it be? You got it. Right. But then part B says the electron is now there. What is electric force? You could do the whole thing over again with 2 different equations and solving it. But since we're smart, we're going to use the net field because the electrons at that point, it is now the test charge. It's experiencing the fields. Well, that's what's to happen here. The net field is the net force over the test charge. We're trying to solve for net force. We have the net field. Let's plug this in here. And what value is Q for the electron? You got it. 1.6 times 10 to the negative 19. But wait, isn't it negative? Magnitude only. That's how we do in the mathematics. And when you do this, you will get a field of an ugly color, 1.056 times 10 to the minus 12 newtons. And which way is the force gonna be? Oh, wait. The field is right. Do electrons move with or against the field? What do you say?
Against!
And now for number 3. In number 3, you kind of talked about in class, and you're a little unsure about it. It reads, 2 spheres have a total charge of 90 microcoulombs. 2 spheres each have their own charges. That's my statement. And then they feel a force when placed a certain distance away. They feel 12 newtons we have 2 equations, 2 unknowns. Now, if you didn't get to this point, I don't know how to start. You should have recognized that since they have 90 microcoulombs together, that's kind of like one math statement. And they have the force equation, that's another statement. We can relate these through a system of equations. Now, I'm going to simplify this to make it look a little better. I'm going to move this over here, divide, and I will get 1.92 times 10 to the minus 9, which is what I get when I divide that and multiply by 12 squared, equals Q1, Q2. At this point, we can try solving for it. Most people feel comfortable putting in this one first, so let's solve for the top for Q1. We're going to put this in here. Quadratic times, I just swallowed my own burp. That was amazing. You can rewind that and put that on YouTube too. Okay. You can FOIL this out if you want and have some fun that way, and that's perfectly fine. And put it back in here and solve for Q1 and have your other value. You will get that's it on the bottom of your paper.